Okay, so let's go to the next one, which is free. So now, if, say, for the group elements other than E, the identity element, the group action has no fixed point, then we say the action is free. So what does fixed point means? So X in some manifold M is a fixed point if there exists, some G in the group such that when G acts on X, let me use the action from some G some G in the group where, say, G is not the identity, such that when G acts on that element of that point, it gives me the same point back. Okay? So then we say X is a fixed point. So essentially what it means that if you have some elements in a group such that when it is acting on this element, it does not take, when it's acting on this point on your manifold, it is not taking you somewhere else. Then we say that that point on the manifold is a fixed point of that action. Okay, so let's look at an example. So the North Pole of, say, or the South Pole are fixed points of the SO2 rotation around the z-axis of SO3. So SO3 acts naturally, SO3 acts on S2, right? So we have defined an action. So, this is let me unpack this a little bit, okay? So the group we are taking is SO3. And the manifold we are taking is S2. But there are points on the manifold, such as, say, the North Pole, say, which is a 0, 0, 1. And so this is the North Pole, say Pn. And the South Pole, which is 0, 0, -1, right? And these points are fixed points of the SO2 action, which is the rotation around the z-axis, right? So here we have an action which is not free. So sigma, which is the, let me just say sigma, which is the action of SO3 on the two-sphere, is not free because it has, we can choose these fixed points if we choose the subgroup SO2 around the z-axis. If we choose a different subgroup, we'll get different fixed points, right? So now can somebody give me an example of a group action that is free?
Translation.
Sorry, can you repeat that?
If we translate an object, that would move every point to a new point.
Sorry, your sound is really bad. Is that Saif?
Yes, sorry, it's safe.
Okay, Saif, can you, your sound is really bad.
Yeah, I turned off the fan. So I was saying translating an object would be a group action where there would be no.
Very good,
points.
yeah. So if I take, say, the translation group, say R4 on Minkowski space, right? So the action of the translation group on Minkowski space, if G is, say, R4 and M is the Minkowski space, then that is an example of the translation of a action without fixed points, right? Yeah, good. Any other examples? So this is free. What about a compact example? This is a non-compact group. Is there any other compact example we discussed today, which had a free action?
On a circle.
Exactly. If I take G to be U1 or SO2 and M to be the circle, then that's also free. There is no fixed point. Okay. Okay, so I think, this is the next one is actually pretty similar, but sometimes gets confused with the free. And number 3 is the effective. A group action can be effective. Okay, so what is effective? So if for all points on a manifold, for all points, so for all, not just there must exist one, or, if for all points on a manifold, the only group element that satisfies G acting on X, giving you X is G equals to E, then the action is effective. Okay. So, for example, so we have to essentially, we have to take every element G from the group and apply it on all the X's. For all the X's. And if we find that for all the X's, that this is true only for G equals to E, then we say that the action is effective. So my question is the group action of SO3 on S2 effective or not? So we take all the G's, right? So, let's look at the elements which are, which leave the North Pole, say, the North Pole fixed, right? So we know that that's actually SO2Z, right? That's a subgroup that's going to keep the North Pole, unchanged. But when it's acting on the other points are changing place, right? So if it's not the North Pole, then the action of this point, of this group, is going to, it's not going to satisfy this, right? So, sorry, it does satisfy this only for G equal to E, right? So that means that the group action of SO3 on S2 is effective. Okay, so an effective action doesn't have to be free. But if the action is free, then it has to be effective. Okay? So this is a little subtle, the difference between effective and free. Okay? So for something to be effective, you basically have to say that, you have to look at all the, you have to look at the action of a group element on all the points on the manifold. Okay. And if, this is satisfied, if this is satisfied only for G equals to E, then it is effective. So can someone give me an example of an effective action? Another effective action. So what about the action of U1 on S1? If I take, if I take some point, say X in S1, and if I apply all the G's on this X, the only time when this will be true is when G is E, right? Okay.
I don't think I got this part. Doesn't SO2Z have fixed points at the north and south pole?
Yes, it does. Yes, but it also has that action on the other points is, does not satisfy this relationship, right?
It has to satisfy it for all X have to be fixed for it to count as effective.
Yeah, it has to be like this and only for this. So there are non-trivial elements of SO2, which, exactly, yeah. It has to be for all the elements. sorry, it has to be for all the points. That's what I mean. It has to be for all the points on the manifold, right? So yeah, this is a bit confusing. So we have a manifold and, you know, we have some group action which takes us from one point to another, right? X goes to X prime, G, say, acting on X. And now, if you find that if you find that this is true, say for all X, but only when G is E, then we say the action is effective. So now, how does this relate to our particular example? Our particular example was that, you know, G acting on the North Pole, so it was P north, which satisfies this thing, right? And of course, this is not, you know, again, this is also not, G is not equals to E, right? So this has no, you know, so, and also there are other points which are not the North Pole on our two sphere, where when this acts, this is not the same point. Right. So,
Okay, so would a 360-degree rotation not be the same as the 0-degree rotation?
yes, it is the same rotation. Yes.
Okay, so that doesn't count. That isn't one for
Right. Yeah. 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 So we see that, you know, this is going to be for SO2, for SO3 acting on S2, you know, this is true, right? That this thing is, you know, if I take any point and then, you know, apply some SO3 action on it, then, you know, this is going to be true only for G equals to E, right? So